Hi everybody, in this video I wanted to show you how to do RabbitMQ service virtualization, API mocking and system simulation. So typically what we see is a pattern where two systems communicate with each other. So we got system A that's communicating with system B using request and response queues. System A will be sending a request message to a request queue, which then gets consumed by system B, and the system B does some processing, and after it's done its processing, it will be sending a response message to the response queue, which then gets consumed by system A. And that's how systems A and B communicate with each other with asynchronous messages. When you're testing in those scenarios, you might have an issue where system B is not available yet. For example, you've decided that you're going to work in parallel. Your team A will be working in parallel with team B, and you've decided what the API or the format of the messages between your teams look like, but team B has got more work, so they're moving a bit slowly and their system is not available yet. And you want to test your system that you've developed, system A, as a team A, and you've got this testing issue that system A sends a request message to RabbitMQ, but there's nothing to consume those messages and produce the response messages. So what do you do in this case to be able to test your system A without having to rely on system B? So what do you do in those situations? Well, you can use system simulation, API mocking, or service virtualization. So in this case, we're using Traffic Parrot. Traffic Parrot will be consuming those request messages, doing processing and producing the response messages. And the way it does this processing or creates the response messages is based on the configuration we've provided it with. So in our example here, we're going to have a vegetable order system, our system under test that I'll be testing, that is connecting to the orders queue and sending request messages to the orders queue, but the order processing system is not available yet. So when the vegetable order system expects messages on their order confirmation queue, it gets nothing there. So how would we be able to test the vegetable order system in isolation when order processing system is not ready yet, because the team that's working on that system has got more work to do and they haven't finished it yet? Well, again, we're using Traffic Parrot here in this example, which I'll demonstrate to you in a second. So stay tuned, please. And we're going to be having the vegetable order system that sends the order messages to the orders queue, which then get consumed by Traffic Parrot. Based on the configuration we've provided to Traffic Parrot, it will create those order confirmation messages on the confirmations queue, and the vegetable order system can be tested that way in isolation because it sends the request messages and gets the response messages back, so we can see how it behaves without having to rely on that order processing system. Okay, so let's have a look at that. I've got my vegetable order system here and I just need to extract it. And the vegetable order system's got a configuration file where I can point it at my RabbitMQ broker, which is running on 10.0.2.2. So right now the vegetable order system knows how to connect to my RabbitMQ, and you can see it's connected. And now we can go to localhost 8282 where the vegetable order system is running, and we can see that this is how it looks like. So I can send an order, for example, for 5 carrots. This has been sent successfully. Unfortunately, see, there's no confirmations found here, so we can't test our system in isolation here without that order processing system, because that order processing system is not consuming those order messages right now and not producing those confirmation messages. So how do we go about this? Well, again, we're just going to use Traffic Parrot to consume those order messages and produce those confirmations messages. How do we do that? Well, I got Traffic Parrot downloaded here. I'm going to extract it, and now I can start it up. The first time it starts up, it usually runs the antivirus, so it takes a couple of seconds to start running. There we go, Traffic Parrot started up, so we can go to localhost 8080 where the Traffic Parrot web user interface is located, and go to JMS add edit, and we'll tell Traffic Parrot here to consume requests from the orders queue and produce response messages on the confirmations queue. And what is the response message body? Well, we know it from the documentation because we've discussed with the order processing team that this is how those messages should look like. Okay, so this is a simple JSON response message body where you got the order name, the quantity, and the date. Okay, so I'll just paste this in the response body, save that, and go to JMS replay, and you can see in here that I've got a mapping where it says the Traffic Parrot is going to be consuming messages from the orders queue and producing response messages to the confirmations queue, and the message body of the response is going to be looking like this. So the only thing we've got left to do is now connecting Traffic Parrot to the RabbitMQ and to the RabbitMQ broker. And the way we do that is configure via the JMS connections file here. and I'll look for a sample for RabbitMQ. There we go. We've got a sample for RabbitMQ. We can just use that. Let's call it my RabbitMQ, and it's running on 10.0.2.2. Username, password, port the same. I can close that, refresh this replay page again, and I should see my RabbitMQ here and my RabbitMQ. Turn this on. So what we've got here is a virtual service running. There's a virtual service is on. So what's going on right now? Well, again, Traffic Parrot right now is simulating the order processing system. It's consuming messages from the orders queue, producing messages to the confirmations queue. How do we know that? Well, it's already consumed that message that we've sent a couple of minutes ago to the orders queue, and it's produced a response. So we can see now that we are able to test this application isolation. So I can send a couple of more messages like this, and you can see right now these order processed, the order confirmations are suddenly appearing here. Traffic Parrot is doing that for us based on those hard code, based on that JSON response we've configured it to respond with. Okay. Right, so right now what we can see is the Traffic Parrot is consuming those order messages and producing those confirmation messages. So we are able to test our vegetable order processing system without having to rely on another team, and we can test our system in isolation. Okay, so we'll notice one issue here though, which is that if I try to send an order for 1 potato, we get a successful order send, but I get a response that says it's still 5 items of carrot that have been confirmed. Why is that? Well, it's because we've told Traffic Parrot to do that. If we go to that mapping, it says that the response is hard-coded to 5 carrots and this date in the past. How can we change that? Well, fortunately, Traffic Parrot supports dynamic responses, so we can generate those responses dynamically. We know that the request we're going to be sending to that order processing system looks like this. It's got a quantity and order name, order item name. So what we can do there is, based on this request, use those attributes of the request in the response and produce a dynamic response. We can use JSON path to access the request body from the request message and access the quantity field or the order item name, and we can also generate a date timestamp in the specific format. So what is that going to look like in Traffic Parrot? This is the sample template. So I'm going to copy that, paste it in here, and you can see that the order item name will no longer be hard-coded to carrot. It's taken from the request body order item name. Same with quantity, it's taken from the request body, and the day is generated dynamically in this format that the vegetable order system will understand. Okay, so I can turn on the replay again here. The virtual service is on, and now if I say send a request for 1 potato, what I should get is a 1 potato confirmation with today's date. Perfect. So what we were able to do here is simulate this order processing system, but in a way that's quite representative of not only the format of the messages, the structure, but also the semantics of the messages, so what those fields actually mean. And we were able to test our application, the vegetable order system, in isolation without having to rely on that other team. Okay, good stuff. So if you wanted to take this further, we would encourage you to, I'd encourage you to check out Traffic Parrot and request the evaluation here on trafficparrot.com. And you can also look at this tutorial, which is on our tutorials page. You can go there step by step through all of the things that I've been discussing here today. We also offer these workshops for our service virtualization and API mocking workshops. We cover HTTP, SOAP, and REST, JMS, IBM-MQ, gRPC, RabbitMQ like this one, AMQP, and more. You can invite up to 10 people from your team, and if you're interested in that, please go ahead to trafficparrot.com and fill in the contact form, or just email contact@trafficparrot.com. Thanks a lot for watching. Give a thumbs up if you liked it, and I'll talk to you soon.